made it up, so it may not be pretty. Are y'all getting an answer?
It's small enough that the
Yeah, that's what I was
calculator won't
thinking, I was gonna
register
try to
it.
change it. We'll leave it as that, but I'll see if I can make the other ones better. All right, we have a normal distribution with a mean of 80, a standard deviation of 5.4. We have one data point which is 62 and it's less than 62. But because we have a group of data, what do we have to do with our standard deviation? We have to redo the standard deviation, so our new standard deviation is going to be divided by the square root of our old standard deviation. So it's going to be 5.4 divided by the square root of 25. So I did normal CDF. Shade begins at -9999, shade ends at 62. My mean is 80, and my new standard deviation was 5.4 over the square root of 25. It ended up giving me 0, but as long as we got it set up good. Are we good? Yay? All right, let's look at another one. If the population proportion is believed to be 0.3, how many items must be sampled to ensure that the sampling distribution of p-hat will be approximately normal? If the population proportion is believed to be 0.3, how many items must be sampled to ensure that the sampling distribution of p-hat will be approximately normal? So there's two things that we must do to make it approximately normal. Okay? I want to know how many items must be sampled to be approximately normal. I think in your homework, in your notes, I said, how many more people do you need? Remember when we had 50 and I said, how many more? This is just saying, how many do you need? To be normal, we've got to use the n is less than or equal to 0.05 times big N, and we have to use the NP, and the 1 minus P is greater than or equal to 10. We can't use that one because we don't know big N. So this is the one that we're going to be using. We're going to be using this one. And it says that we need to know how many items, so we're trying to find the N. So we're going to do N times, what is my P? 0.3, what is my 1 minus P? 0.7. So I'm going to clean up my 0.3 times my 0.7. It's going to give me 0.21. So N times 0.21 is greater than or equal to 10. I'm going to divide both sides by 0.21. 10 divided by 0.21. And no matter what, we are always going to round up. Number one, you can't have part of a person. And number two, if you round down, you're not going to end up with enough. Always round up. So N is going to be greater than or equal to 48. Cool? All right. Suppose X is a uniform random variable with values ranging from 20 to 80. Find the probability that a randomly selected observation is between 28 and 63. So this is not a normal distribution, this is a uniform distribution. This is where we made that little box, and we did the length times the width. I think Rachel even asked me to do one on the homework. Do I need to do it? I'm getting that look. This is when we had, it goes from 20 to 80, so we started at 20, 30, 40, 50, 60, 70, it ended at 80. And it came straight across, 20, 30, 40, 50, 60, 70, 80. And the number up here is 1 over how far it is from here to here. So how far is it from 20 to 80? 60. So I did 80 minus 20 and I got the 60. That's where that 60 came from. We good? Now our two data points are 28 and 63. So 28 and 63. So that's going to be the width of my box. So I want to know the shaded area there between 28 and 63. So when you're doing the area of a box, you need to know the length and the width. How wide is the box and how tall is the box? Well, we know that the height of the box is 1 over 60. So the height of my box is 1 over 60. I now need to know how wide my box is. How do I get the distance of that box? How do I get that length? How far is it from 28 to 63? 63 minus 28 is what? $35. So now I'm going to do area equals length times width. So we have 35 times 1 over 60. I'm going to do length times width. So I go to my calculator, 35 times 1 over 60. There's my answer, however they want me to round it. Are we glad we're reviewing? Cool? All right.
So
Yeah.
values ranging between 80 and 20, that's inclusive.
Yes.
So there's 61 values between 80 and 20 if
Then
you're
it may not
including
be
both.
inclusive.
Okay.
Yeah.
And the same thing goes for 63 and 28.
Right.
So it would be, if it's inclusive, it would be 36 instead of 35.
Correct. Correct.
Okay.
Approximately what percent of the area under the curve is between the mean equals 3 standard deviations, or plus 3 standard deviations, and the mean equals minus 3 standard deviations? This is kind of old school, but we've still been doing it. If you have the mean, and you add a standard deviation and you subtract a standard deviation, what percent is that? One deviation and one, yeah, okay. Let's not look at this one. So if you have the mean, and you add a standard deviation and you subtract a standard deviation. So what is one deviation in either direction? What percent was that? 68. Then if I have the mean and I add 2 deviations and I subtract 2 deviations, what was that? 95. So now if I have the mean and I add 3 deviations and I subtract 3 deviations. So this is saying that I'm starting with the mean and I am adding whoop, 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 and I am subtracting whoop, whoop, whoop. So if you are within 3 deviations, you are 99.7%. If it was 2 deviations, that would be 95%. If it was 1 deviation, it would be 68%. Yay? 3 jumps is 99.7, 2 jumps is 95, and 1 jump is 68. Suppose a population means average is 250 tons with a standard deviation of 36 tons. A sample of 49 items is drawn from a population. What is the standard error of the mean? What did I tell you that the standard error of the mean was? It's the same as the new standard deviation. So all they're doing is telling you, give me the new standard deviation. So when they ask for the standard error of the mean, they are saying, what is the new standard deviation? So all they want to know is the new standard deviation. Is the old standard deviation divided by the square root of the size of the group. So what is the old standard deviation? The square root of the size of the group? So it's going to be 36 over 7, or whatever that decimal equivalent is. So the standard error of the mean is just telling you that they just want to know. They didn't say find the probability. They're not asking you for shading. They're not asking you for z-score. They are saying, what is the standard error of the mean? They are saying, what is the new standard deviation? That's all they want to know. Professor Cooper asked 200 students their favorite color. 120 said pink, because that's my favorite color. What is the sample proportion, p-hat, of the students who like pink? What is the sample proportion, p-hat, of students who like pink? How did you get it, Courtney? All I wanted you to do was turn it into a percentage as a decimal. How many like pink over the total? We did that back in 3rd grade, back in Math 33. I'm just making it sound a whole lot fancier. How many like pink over how many people did I ask? The mean is 7.2. Standard deviation is 5. A random sample of 81 were observed and the mean was calculated. Describe the sampling distribution of the sample means. Example, is it normal or not? And what is the mean and standard deviation? Okay, so is it normal or not? Meaning, is the, hold on, where's my paper? This one. Describe the sampling distribution of this. Is it normal or not? In order for it to be normal, there's 2 ways to figure out as if it's normal. There's a way if it's a P, and there's a way if it's an N. If it's a P, you've got to do those 2 formulas. If it's an N, it's got to be a certain number. Is this a P or is this an N? This is an N. So in order for it to be normal, is it normal? What does our N equal? 81. To be normal, what does N have to be? Greater than 30. So is it normal? Yes. If this was a P problem, we would have to do those 2 separate formulas. So yes, it's normal. Now, because it's normal, they now want me to figure out what is the mean and what is the standard deviation. So, what is my mean? 7.2. What is my standard deviation? What is my new standard deviation? 5 divided by square root of 81. Okay? Find the area under the curve, a standard normal curve.
Does it have the answers for new standard deviation are gonna be, they're not gonna want what 5 divided by the square root of 80?
They're going to want it as 4 decimal places.
Okay.
Yeah. So they're going to want 5 divided by the square root of 81 close. They're going to want that to 4 decimal places. Yeah. Find the area under the curve. Standard normal curve between z equals negative 1.25 and z equals negative 0.25. So we're doing area under curve. What kind of problem is that? Normal CDF. What is my mean? Zero, because it's a standard normal curve and I did not give you a mean. We're doing a z of negative 1.25 and a z of negative 0.25, and I want to know between. So it's a normal CDF. Where did I begin shading? Where did I end shading? What is my mean?
0.
And my standard deviation. So you're going to be thrown every type of problem, and you're going to have to know, holy crap, what do I do? Let's look at another one. 27% of people consider going back to school. If a sample of 600 people were asked, what is the probability that between 275 and 300 are going back to school? Is this a Chapter 7 problem? Is this an 8.1 problem? Or is this an 8.2 problem? Or is this I have a no idea problem? What is my mean? What is the mean of this problem? 0.27. Which means that all the numbers down here have to be what? Percentages. Yay? So all the numbers down here have to be percents. So can we put 275 and 300? No. How am I going to get my numbers down there? Who? 275 over. How many people did I ask? 600. 300 over 600. So if I go to my calculator, it's going to be 275 over 600. So I just turned it into a percentage. And then it's going to be 300 over 600. And you can tell I made it up because they're crappy numbers. So I'm going to be going between 0.4583 and 0.5. Now, how do I get my standard deviation? Okay, so my new standard deviation is going to be
The whole standard deviation divided by the square root
because this one didn't say, I mean, it did have sample, But because we're dealing with P, it's gonna be P times 1 minus P over N, because we're dealing with P's. This is where that practice is gonna get you. So it's gonna be the square root of 0.27 times what is that, 73? Over, how many people did I ask? 600. So my new standard deviation is gonna be the square root of 0.27 times 0.73 divided by 600, close it. So that is going to be my new standard deviation, is going to be 0.018124. So now when I do normal CDF, it's where shade begins, where shade ends, my mean and my standard deviation. So if I type that in, it's going to be second VARS normal CDF 0.4583, comma, 0.5, comma, 0.27, comma, 0.018124. And what should that answer be? 0. Because that's telling me that I went 33 times to the left, so it's going to be 0.000000000 blah. So that's going to be 0, which means I made it up, which means it was a crappy number. So that gives you, and I'll put out a few more on Wednesday if you want me to, because I know most of y'all won't take the test till next Monday anyway. Now, on your formula sheet, let me show you what your formula sheet does give you. I can figure out which page I had it out there on. No, that was there it is. Okay, so under 8, what is this test on? 7 and 8. So on your formula sheet, under 7 and 8, which is what this test is on, this one is reminding you that your z-score is equal to the data minus the mean over the standard deviation. That's reminding you of that. This one is reminding you of what we did with the 68, 95, 99, 7 rule. That if you take your mean, and then you're taking like a z-score plus a standard deviation. So your mean plus 1 standard deviation, your mean plus 2 standard deviations, that's really all that's saying. Now, down here, this is saying that your mean is your mean. Your mean is always going to be your mean. Your new standard deviation is going to be your old standard deviation divided by the square root of the size of your group. Over here, your mean is going to be your P, or your percentage, but your mean is your P. And your standard deviation, when you're talking about percentages, is going to be P, 1 minus P over N. And then this is saying, hey, if it's not in a percentage, do X over N. That 175 over 600 or whatever. But what's not out there are those 2 rules that tell you, is it symmetric or not? And that N has to be 30 in order for this to be symmetric, and those 2 rules of what it has to be symmetric for P to be symmetric. P had to be symmetric. So you're going to have to memorize those. Okay? So when we come back on Wednesday, I'll answer any questions y'all have on 7 and 8, and I will start on chapter 9, and then homework is technically not due, not this Sunday, but next Sunday, but I would not hold off because you really need to do that 7 and 8 homework to be ready for that 7 and 8 test. And that 7 and 8 test is due a week from today. I am done unless y'all have questions. Oh, you put no.